In this video, we're doing a couple basic definite integrals with exponential functions. And the first one is just our basic natural exponential function. It's equal to its own derivative. And the fundamental theorem of calculus tells us that to compute a definite integral, in other words, the area bounded by a curve on some interval, all I have to do is guess the antiderivative of the integrand. Well, that's just e to the x because it's equal to its own derivative. And then I evaluate that across the limits of integration. So I plug in the right end of the interval. I subtract the result that I get when I plug in the left end of the interval. And e to the 1 is just e, and e to the 0 is just 1. And I get my area, e minus 1. There's a complication in the second example. So just as a reminder, the derivative of 2 to the x. That gives me natural log of 2 multiplied by 2 to the x. So what do I do to get the antiderivative of a 2 to the x? Well, I have to prepare myself for that extra factor of natural log 2 to appear. So the antiderivative of 2 to the x is 1 over natural log 2 times 2 to the x. Because when I differentiate that 2 to the x term is going to produce a factor of natural log 2 and cancel the one that I prepped out in front. Then I evaluate from 0 to 1. And when I plug in the upper limit, I get 2 to the 1, which is 2. When I plug in the lower limit, I get 2 to the 0, which is 1. 2 minus 1 is just 1. And I get a final answer of 1 over natural log 2. And we're done with that one. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.